Hey friends, we are in chapter 8 and we're looking at linear functions and graphing, and specifically today we're going to talk about systems of equations. This is a concept, this is a topic that we're going to talk a lot more about in Algebra 1, but as pre-algebra students, I think this is a fair time for us to at least consider this concept and see what it's all about. So let's get started. The first thing we need to do is take a look at the vocabulary. We have only two vocabulary terms today, the first of which is systems of equations. And basically what a system of equations is, you're going to find that you'll have an equation, maybe something like this: 2x plus 3y equals 4, and x plus 2y is equal to -7. So if you have something like this where you've got a collection of two or more equations with using the same variables, that's considered a system. And the cool things about systems is sometimes you can have two variables that you could look at in two different ways and then find out where those two equations share the same solution, meaning the x and y value for one works as the x and y value for the other. And that's what we're going to be looking at shortly when we actually start solving these. Now there's two methods that we're going to discuss in pre-algebra to solve them, and one of them is called substitution, and that's our next definition, and the other one is graphing, and you'll see that first. So our next definition is substitution. It's a method of solving systems of equations. It's going to be akin to the idea of, you remember earlier on we might say s is equal to 4, so find 4s plus 3, and you'd substitute that value in to figure out what 4s plus 3 is, and in this case, just doing it for kicks and giggles, we get 4 times 4 is 16, because we know we've got to multiply first, add 3, and then we get 19. Substitution is going to be similar to that, except instead of just substituting a number, we're going to substitute an expression into another equation. So you'll take a look at that and make sure that that's a key hallmark of solving systems of equations that you're going to need to know. So only two ways, graphing and using substitution. And let's get started by looking at an example where we can graph. So here is a system of linear equations. So we've got y equals x and y is equal to -3x plus 4. What we're going to do is graph the two lines that represent these two equations, and we're going to see where they intersect. That intersection point is considered the solution for the system. Let's get started. Okay, so I've chosen to transpose those problems onto a different program so I can actually graph a little bit better. So we have y is equal to -3x plus 4, and I've written it in black because that's how I'll graph it, as the black equation, and then y equals x, which will be graphed as the red equation. So if you guys remember how to graph, if I'm going to graph the first one, let's see. If you guys remember how to graph, we know that it is necessary. We can use many different ways. We can use a table. I don't think we talked about x and y intercepts. We use a table, something called x and y intercepts, and we can also use y equals mx plus b slope-intercept form, and I think that's what we're going to use here. So I see that for this first equation, the black equation, my y-intercept is at 4, and my slope is m, in this case, is -3 over 1, which means that I go down 3, 1, 2, 3, and to the right 1, or I could go up 3, 1, 2, 3, and then to the left 1. In each case, you see that we're going to be on the same line. So here, did I do that right? Down 3 and over 1. This one is not correct over here. Down 3 over 1, down 3 over 1. So these 3 points that I'm highlighting here are definitely on my line. So I am going to grab a line drawing utility, make sure it's black, and do my thing. And so here's my line. All right. And when you draw a line, sometimes you want to extend it out as far as you possibly can in order to make sure that you can find the intersection point. My next equation that I want to graph is y equals x. And since it's going to be red, I'm going to choose my red pen. And in a sense, this is like y equals x plus 0, right? Because there's nothing being added to it. So y is equal to 1x plus 0. I haven't changed the value. But the reason why I've done that is to really highlight what the y-intercept is and to highlight what the slope is. So the y-intercept is 0. So this is where my graph is going to cross the y-axis. And my slope is 1. So if my slope is equal to 1. That's 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. Or I could go down 1 in the negative direction, back 1, that's negative. So a negative over negative gives me that positive 1 slope. Notice no matter how I interpret that, I'm going to get the same straight line. So again, I'm going to go grab a graphing utility that's going to give me access to a red line, and I'm going to graph and make sure that my line goes through all of those points. Now that I've done that, I can see clearly where the intersection of my 2 points are, and that intersection is located happily at what we're going to call the solution 1, 1. So a point that satisfies both of these equations would be 1, 1. When x is equal to 1 and y is equal to 1, we're going to get a solution for both equations, and we can quickly check it. If I put a 1 here, is that equal to negative 3 times 1 plus 4? I think we can see that it is. And of course, if I put a 1 here, clearly that's equal to 1. 1 is equal to 1. If x is equal to 1 and y is equal to 1, that's the solution for that equation. So that's what we're doing. When we solve systems of equations, we often graph them, and we're looking for that intersection point. Let's check out a few other examples. So here we are at example 2 with an application, kind of a word problem situation where we're going to use this newfound skill of creating systems of linear equations and then solving them, in this case probably by graphing. So Marjorie and Brian are selling magazine subscriptions. Marjorie sells 3 times as many subscriptions as Brian, and Brian sells 12 fewer subscriptions than Marjorie. So what we need to do here is, the first thing we're asked to do is to write a system of equation to represent the situation. Before we do that, we need to use variables, and sometimes my 8th graders do this. They'll say M is Marjorie, B is Brian. And it's a little shaky, and I'll tell you why. Anytime we're using a variable, that variable is representing a number. So we need to have a quantity when we are defining our variables, not just say M, Marjorie, B, Brian. So what we will say is that M is the number. And that's always a good way. What is the variable? It is a number that describes something. So you want to start there. So M is a number, is the number of subscriptions that Marjorie sold. I think that's supposed to be a J. You guys will forgive me. That Marjorie sold. Okay? And B, similarly, is the number of subscriptions that Brian sold. Okay? So with that in mind, now we're dealing with numbers. And so these letters that are representing numbers are going to be really significant to us. I'm going to do something kind of weird. I will come back to this, but I just want to get it out of the way so I have some space to work, and we'll come back and reveal what that question was again. So back here, now that we have that, we're still trying to write a system of equations that represents the situation. And so we go back and we look for details. It says Marjorie and Brian are selling magazine subscriptions. Marjorie sells 3 times as much as Brian. So if I put Marjorie and Brian, now we're comparing Marjorie and Brian. So the number of subscriptions that Marjorie sold, the number of subscriptions that Brian sold, we're comparing them. We need to figure out how 3 can make this thing equal. Now, what people sometimes do is say, Marjorie sells 3 times as much, so M times 3 equals B. But that's not what this is saying. Marjorie has sold more. Not just more, but 3 times as much as Brian. Okay? With that in mind, we need to find a way to equal this out to create an equation. To put a 3 here, when we know M is 3 times as much as Brian, skews this thing so it's not equal. What we need to do is balance it out by using the 3 here. If I say Marjorie has sold 3 times as much as Brian, then that means in order for them to be equal, I would have to multiply Brian's amount by 3. And that's what helps me locate where I'm going to put that number 3, the coefficient. So M is equal to 3B, and the next equation we have is going to be here. Marjorie sells 3 times as much as Brian. Brian sells 12 fewer subscriptions than Marjorie. So if we think about Brian, we know that he has sold 12 fewer. So if we again set up Brian and Marjorie to be equal, they're not, but we can balance this by considering this piece. So there's two ways we can actually resolve this. I could add 12 to Brian and then it would be equivalent to the amount that Marjorie sold. Or I could subtract 12 from Marjorie and that's now equivalent to the amount that Brian sold. So this gives us our two equations, and many people feel uncomfortable with using M and B because we're so used to X and Y, particularly since we're going to graph. So I'm going to just put, okay, let's let X represent Marjorie's subscription numbers and let's let Y represent Brian's. So our equation is going to be X is equal to 3Y, and our equation will be Y is equal to X minus 12. So now we've got two equations, and now we need to figure out how to graph it. So the next piece, what we were asked here, let me get my little eraser. We were asked to solve the system by graphing and explain the solution. So I'm going to use another page to do that. I'm going to grab these two equations and bring them to another page so we can solve it. Okay, so what I want you to notice is that we have X as Marjorie's subscriptions and Y as Brian's subscriptions, but I want you to notice that there's no real use in using the negative portions of the X and Y axis because you really can't have negative subscriptions, right? So I'm using the only part that I need, and I'm going to graph Y equals X minus 12 and X is equal to 3Y. I hope that this feels uncomfortable for you. Not that I hope that it does, but I hope you know that we can relieve that discomfort by simply solving for Y. And the reason why we would do that is so we have it in Y equals mx plus b form. So I have Y equals x over 3, which can be written as Y equals 1/3 x. Okay, and I guess plus 0 if we need to. So now I'm going to rewrite both of the equations that I'm needing to use. Well, I'll just write this one over in red. So I'll have my red equation and my blue, in this case dark blue equation, 1/3 x, and I'll put the plus 0 here. All right. So now that I have that, let's go ahead and graph the equations that we need to graph. Okay, so what I realize is as I have Y equals X minus 12, this doesn't really make good, I can't go to the negative 12 and then go slope up as I'd like. So I'm going to have to be a little bit creative. The reality is I only need 2 points to create a line. So here, Y equals X minus 12. Since I didn't have the negative portion to graph that y-intercept, I'm going to just choose values that are going to work for what I need. So here's x and here's y. I'm going to choose some x values that can work. So I realized that if I put 12 here, when x is equal to 12, y is equal to 0. And if I put, let's say, 14, when x is equal to 14, y is equal to 2. These are 2 points that are going to get me a line. So I'm going to go out to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And at 12, y is equal to 0. And then the other point at 14, y is equal to 2. So these are 2 points for my blue equation. Let's graph it. Okay, got that. The next thing I need to do is graph this red equation. Y is equal to 1/3 x plus 0. So in this case, I do have the luxury, let's say, of using slope-intercept form, because if my y-intercept is 0 and my slope is 1/3, that means go up 1/3, up 1/3, up 1/3. You guys see how this is going? Up 1/3, up 1/3, up 1/3, up 1/3. Okay, so I'm going to now connect those dots like that. And though I did not get to go as far as I wanted to here, I can already see where the intersection would be. So the intersection would be, this was 14, 15, 16, 17, 18. At 18 and 1, 2, 3, 4, 5, 6, 6. All right, so what does this mean for our problem? What does this mean? How does this, what's going on? Remember, X was the number of subscriptions that Marjorie was able to sell, and Y was the number of subscriptions that Brian was able to sell. So X refers to the 18 subscriptions that Marjorie sold, and Y refers to the 6 subscriptions that Brian was able to sell. All right, so let's take a look at one more or 2 more examples. I think I've been overexcited and I didn't look at the time. I don't think we have enough time to go through these two examples, so we'll make a part two. Here are our two examples. One, we're going to look at different solutions that we might get, and this second example we'll see in the next video. We'll talk about substitution, which is really handy. I can't wait to see you guys in class, and I look forward to talking to you. Check out the next part. Bye-bye.